What's happening? Mohawk Matt here once again, and today I have a fantastic person for you all to meet, Dr. Sandra Chapman. How's it going, Sandra?
Good. Thank you for having me.
Super excited to have you today. Sandra here, or Dr. Chapman, as I call her, she is the program officer of the Undersea Medicine program for underneath or inside of Office of Naval Research inside the United States Navy and Marine Corps kind of blended together. Correct. So Sandra, tell us a little about what you do undersea.
Well, I don't do much undersea. I have gotten certified with my diving certificate since taking on this program, but I help military divers stay safe.
That is important. Safety is key when you're underwater, I'm sure.
That's right. Humans were not built to be undersea, and so there's a lot that we have to think about, protect them against, and work to better understand how the human body adapts or interacts in the undersea environment. And there's a lot of different factors undersea, the main one being apnea, not being able to breathe.
Which is kind of critical.
Having depleted oxygen is critical.
Yeah.
And that has a lot of nice spin-offs to, heart attack, any way that we can help adapt the human body to sustaining prolonged time spans of being without oxygen has multiple beneficial implications.
Okay, that's very cool. And I heard a rumor that you're kind of working on something related to Aquaman.
That's right.
Kind of real life example.
Yeah, so I keep a Lego figure of Aquaman up on my desk to remind me that my goal is to figure out how to turn us normal mortals into a superhero Aquaman, somebody who can seamlessly transition from land to sea without all the artificial equipment that we currently use. All the engineered solutions, scuba gear, wetsuits, they all encumber the diver or warfighter who needs to be super agile, super able to be independent and seamlessly transition in between different domains. Yes.
Well, in that gear, I mean, if you're going on whatever you're up to out there, if you're doing something and you got all this gear with you, it gets heavy. Even, underwater, probably not as heavy.
Right.
But once you transition to land, it is, I'm sure.
Yes.
So your future state sounds like kind of that human evolution of that Aquaman ability where you can transition, and which is fantastic. What about currently? Like, what kind of things is your department or your organization doing now with equipment or ways to support people undersea?
Yeah, so the beauty of ONR is that we get to play in multiple different domains of research, so from basic, applied, and advanced. So we get to kind of hedge our bets and invest and do research in the really future, far forward-looking areas. So some of the areas that I might talk about later that are more futuristic. But we also have some more near-term projects so that we can deliver something to our customers, our community, the warfighters, in a reasonable time frame. And so my projects span from the most advanced is going to be delivered to the warfighter relatively soon, and that's an augmented reality heads-up visual display in the diving helmet. Wow. And so visibility can often be a big issue underwater. Not only is it dark, but often very murky. And also you don't have good sense of where you're at, if there's a shark behind you, the real important thing.
Shark detector going on, radar, sharkdar.
So this is a equipment that has from topside sonar scanning and then can deliver those imagery to the diver in their helmet. That's something that is already under development. But of course we have bigger goals with that. We would like the diver to be able to have heads-up display of what is going on internally with their body physiologically, what the medical concerns might be. These are technologies that we don't have right now. There is no underwater physiologic monitors. So the Apple Watches or the Garmins that we all take for granted have very limited abilities underwater, and that's mainly because the health concerns that you face underwater are not what you face on land, and so not many people are investing in these areas of research. And so generally the field of diving medicine moves fairly slow because it's like a niche, you know, market. It's a niche area.
Definitely. So I also heard a rumor about a gills program. Can you tell me a little bit about what the gills program is and kind of what that technology involves?
Yeah, so scuba gear technology hasn't advanced much for a while. It's generally really efficient. It works, but because it's been the same basic technology for a long time, it's bulky, it's big, it's heavy. And so when I first got to ONR, I just started thinking, how can we revolutionize scuba gear? How can we make it better? And again, I always have Aquaman, and you know, sitting on my shoulder, telling me ways to take the program. And in this particular case, I thought, you know, why are we taking oxygen from surface supplied oxygen down with us in these huge heavy tanks? Why don't we utilize it as a resource that's already present in the water? Many people have attempted this in the past, but have failed because they've done the very traditional, they've tried to mimic gills, and gills extract the free molecular dissolved oxygen in the water. But that's problematic because there's never going to be enough of it to sustain the metabolic demands of a human. And also it varies. There's less of it in warm water. Throughout the depth column, there's variable amounts. And so as I was thinking about this issue, I thought, well, water, H2O, oxygen is everywhere you are in water. And so then I started thinking about changing the nature of how to think about supplying oxygen from the water. And so now we've gone the route of electrolysis to split water and get oxygen that way, which then, number one, you always have it. And so you can have an unlimited supply. And number two, it doesn't vary in water temperatures, and so it'll always be there for you. So we have.
Is that something we're close to? Is that something that's 20 years away, 5 years away? What's?
Yeah, well, actually, the researchers that I have working on this have been fantastic and have really been producing results and publications, finding the catalysts needed to make this an efficient process and be able to perform this in dirty, you know, messy, mucky seawater instead of normally electrolysis has to be performed on ultra pure water. And so those are the challenges to work out, but they've been making great strides, and so we're actually trying to accelerate this by complementing the basic science that they're doing, finding the, you know, resolving the chemistry, but now finding someone to actually create the mask that will embed these catalysts and be the engineered product that will enable this technology to advance into product development.
I guess it would be pretty amazing if we could all just use that magical seaweed from Harry Potter.
Yeah, the gillyweed.
The gillyweed and grow the gills, that would be great. But since we're not there yet.
Well, those are the long-term goals, right? You know, I mean, I don't know about gillyweed, but I think that we can learn, the best model for us to use are the marine mammals. Because they have similar metabolic demands that we do. And so this is an area of research called comparative physiology. And so we're trying to look at some of the adaptations that they've developed And we even have one researcher in the program who's looking at humans who spend more than 90% of their lives in water. It's a group of people called the sea nomads. And she's doing genetic evolutionary screening and found that they have enlarged spleens. And the spleen can actually be thought of as your own human scuba tank, because it's a reservoir of blood cells which carry oxygen, and so it's like your own store of oxygen supply.
So Sandra, tell us how you you told us a lot about some of the great things you're working on. How did you get here? Where was Sandra 20 years ago? How did you become involved in all of this?
Yeah, so I was really interested in biomedical science when I was in college. And then I joined a lab, and that really, I'll never forget the first time I precipitated DNA, and that means you can see it.
Wow.
And that just blew my mind, and I was in. So then I applied to grad school, and that was a journey. Everything in my life has been a journey. I've gone everywhere. And it landed me in a joint partnership program between my home institution, which was Penn State, and the NIH. So I did 3 years of my PhD at Penn State, and then through a collaboration did my last 3 years of grad school at the NIH. Actually,
NIH is?
National Institute of Health. So actually I was in the National Institute of Allergic and Infectious Diseases, which is Anthony Fauci.
Okay.
And so I worked in his institute at the National Institute of Health. So after I graduated, I joined a Science and Technology Policy Fellowship program through AAAS.
Okay.
And that allowed me to start analyzing how we measure successful science and thinking about more broader questions about how the U.S. government funds or invests in good ideas, and how to analyze that, and how what kind of metrics to use. Yes. And so I did that through the fellowship, and then that experience allowed me to transition after the fellowship to the Office of Naval Research, where I supported the Director of Research, who wanted help to think about a lot of these questions. Yes. You know, how do you analyze different areas of science, because they have very different, you know, metrics, kind of, to some areas of research are inherently more applied, some more basic, and so the standardization across fields was always of interest to me.
Fantastic. Very cool. So where are we going in 20 years? Where's the future of the things that you're working on? Is it evolution? Is it temperature? Is it where do you think this is going?
Yeah, I mean, you know, again, I think the most important thing is to figure out how to adapt the human, because biology is always the smartest solutions. It's always going to be the solutions that make the human most independent. Okay. So temperature control is a real issue for the divers, because water conducts thermal energy 25 faster than air, and so divers will get cold in water, or any human will be cold in water faster than anybody on land. And so in thinking about this, I mean, we obviously know that the current solution is a wetsuit, or in extreme cold, a dry suit. Sure. But again, these are solutions that are inherently flawed, because you're depending on these engineered solutions. And so, like in the case of a dry suit, anytime that dry suit has a rip, and military divers are particularly vulnerable to that, because they're often in areas of sharp metal objects, sure, or even tight spaces. And the minute those dry suits rip, you've lost your thermal protection completely. Okay. And so some of the things that my program has thought about are creating your human body's own thermal or thermostat. So the skin microbiome, I'm sure most people have heard about the microbiome, which are the bacteria that live with us. Okay. So symbiotic relationships, they're actually thought to occupy 60% of our body's mass. And so it's interesting to think, you know, who are we? Because most of us are bacteria. But our skin has a layer of this microbiome. And so we're looking at ways to engineer these bacteria to sense and respond to thermal changes. Wow. So that when it's cold, we can engineer genetically a process for them to generate heat. Or, you know, conversely, and this is the beauty of biology, that it can be fine-tuned, that it can sense and respond to warm water. Okay,
sounds pretty exciting. Excellent. Well, thank you everyone for joining us today. This has been really exciting for me to be able to learn from you, Sandra, and really excited to introduce you all to Dr. Chapman and the work that they're doing over at the Office of Naval Research in the Undersea Medicine Program.
Yes.
Is that correct?
Yep.
Excellent.
Nailed it.
Nailed it. Fantastic. I'll be working there tomorrow. Who knows? Probably not. I don't know anything about it. But really appreciate you all joining, and we are really excited to hear about how where you think we are and where you think the Navy and the Marine Corps is going with this science and where this science is going. Can't wait to hear from you. Have a fantastic day, everyone.